Okay, welcome back. What we want to look at now is principles and properties of magnetism. And we don't just have magnetism happening within a magnet. We need to know how to use that magnetism to an effective force. Okay, so I'm hoping that what I show you now, you will be able to apply it for yourselves and do some additional groundwork so you gain a wider understanding as to what I'm trying to say. Okay, now again, remember, you got to apply this in your own style of learning. Okay, I don't profess to know your style of learning, but this is how I view it for myself. Okay, now here what I'm trying to do, make sure that everything is large enough to be seen and can easily be read. Okay, that's my idea. And let me see if I can put certain things in color. Okay. Now, what I'm saying here is principles and properties of magnetism, and it's by myself, Mr. Terence Payne. Okay. Now, an iron ring of radius 160 millimeters and of uniform cross-sectional area has a coil of 400 turns wound uniformly over it. Now, uniform meant is wound in sequence. Okay. If the current passing through the coil is 4 amperes, calculate A. The magnetoforce, B. The magnetizing force, C. The total flux if the cross-sectional area of the iron ring is 500 square millimeters and the flux density is 1.5 teslas. Now we're talking about teslas, but this is nothing to do with the Tesla car. Okay, it's just that that's the unit of measurements we use in regards to flux density. Okay. Now I'm going to be doing this in 5 sections. Okay, 5 sections, sorry, let me rephrase that. 4 sections. Okay, so there's going to be a part 1, part 2, part 3 and a part 4. Okay, that this is simply to make it easier to understand, so I'm trying to make sure that I do it in bite-sized chunks. Okay, that's the idea. Now I'm not going to go for this for you, but you can see here what we have done here. What I have done here is that I have extracted the information. B equals 1.5 Tesla, I is 4 amps, N equals 400 turns, etc, etc, etc. Now you then need to know how to put this into using the correct formulation. Okay, and here we have F equals IN. Okay, I is the current, N is the number of turns, 400. Now here, the magnetic motive force is 1600 amperes. Now reconsider this for me. You could look at this carefully, because make sure that I've got this right, because I'm thinking of something else in my head at the moment and just need to be sure that what I'm thinking, I have not missed it out. Okay, so it's important that you yourself look at this to be sure that you have got the right reference. Okay, and here we're looking for the part B, the magnetizing force, H. And that's 1592 amps per meter. Now the flux density is Weber. I call this Weber. You can call it, well, I call it Weber. Weber, yeah, or Theta. But Theta could be something else again. But don't worry, I always have problem with my symbols, okay? So it'll be a matter for you to look this up and make sure you understand and check that it is correct symbol that you're using, okay? Especially if you come into an exam, okay? Now here is some exercises I would like you to undertake, okay? Now I have not given you the answers to these just yet, but I will do in a moment. But I want you to have an opportunity to do them for yourself before I give you the answers, okay? Okay, let's go back up and let me now reveal the answers to you, okay? Not here. And make sure that the answers that has been shown is correct. That is your answer, okay? That is your answer, okay? Here I've lost my coloring, so obviously the answer is there, so you can see it there for yourself, okay? The answer here, 10.6 amps, 1.5 Tesla, okay? This one here is, let's have a look at that. Okay, quite large in itself. Okay, there's quite a good few number of parts to this question. Okay, so Yes, your answer. Okay. And here we come to question 7. Now, this question here, I would like you to have a go at yourself. You've been given enough information for you to resolve this matter for yourself, okay? So that's something I would like you to have a go at. No, question 7, okay? Solution for 6, question 6. Let me just look at this, question 6. What did question 6 say to me? Explain the terms magnetic flux density, and magnetizing force. Alright, a coil of 450 turns. Let me see what I did. Okay, solution for question 6. Right, I have to admit here that I'm a little bit, I must have looked at the question 6 somewhere else, or there's something I'm missing, and put it down as question 6. So allow me my errors. I'm not going to change anything, because it's quite possible that I'm talking about the same thing. Yes, okay. This is my, have I got a marker here? This solution here, this question here, solution here, applies to this question 6 up here, okay? Applies to this question 6 up here, okay? And so I was looking at the right thing in my mind, okay? All right. These things pops up at the most inconvenient time of all. Okay. So looking at this, you must follow the procedure as laid down. If you deviate, you will get lost. We need to find the current in the circuit first. We know that R equals V over I. We need to transpose for I current. Therefore, R times I equals V over I. We multiply both sides by I. Okay. Therefore, I equals V over R. Now be sure that you understand the concept how we achieve that, okay? I equals V over R, okay? Because we want I to be the main item. Therefore, I equals V over R equals 12 over 5 equals 2.5 amps. We now need to find the force. Therefore, see if we can make this bigger. If we can enlarge it a bit. Can I make it bigger? Yes. Let's see if I can go with 18. Yes. Okay. And just make sure that it can be seen. Okay, so you have F equals I times N, 2.4 times 450. And where did we get the 450 from? we know that it was given in the question, and it's the 450 terms that we took from here. Okay, so I know I'm on the right track. Don't worry, I make mistakes as well, but I'm not removing any of them. Okay, the idea here is that we can learn from our mistakes, and I can learn as well, so I have no problem in that. H, that's the magnetizing force. That's how strong that the force of that magnetism is, basically. Okay, and 2.4 times 450 over 500 times 10 to the minus 3. Now 10 to the minus 3, okay, gives you 1080 over 0.5, gives you 2160 amps per meter. Okay, now you need to apply this for yourself and find your own style of learning. All I can do is give you a fundamental basis, but it is up to you to write out these questions and make them your own and look at how they have been resolved. Okay, you cannot guess at it. Okay, now here you are required to answer the following questions. You must also complete at home, no exceptions. Okay, I should have colored these boxes here so that they stand out. I wonder if I can do it now. Would it make any difference? Would it give me an option to just say I could highlight yellow? Let me try that and see if I can. Can I get into the box? Now something here give me something about fill the box. Fill the box. Next, fill. Why do I get remembering something? Fill. I don't mean fill as in fill a person's name, but I mean fill as in fill in the box color. I like font color. What I had to fill here to fill the box in. I'm sure I should get that when I click on you. No. Darn crumbs. Okay. Okay, I'm gonna have to leave it for now. Before I had to fill here, edit. Background. It has to be light, so let's give it simple light. No. Damn. Okay. It's okay, we'll just try and do something else here, but it hadn't quite turned out the way I wanted it to do. Okay. Oh, no. Sorry about that. I'm not making any excuse on this part. No. Okay. And that's where we were. Okay. And that's where we were. So I was trying to get the page. Okay, thank you. Okay, I hope you found this useful. Okay, let me just see if I can make this bigger. Can I make it bigger? Can I make this page bigger? I think. Or is it big enough? You think? Let's see if I can what I can do with you here. A second. Okay. Okay, I think I've got as far as I can go at this point. Thank you. This is part 1, okay? And thank you. I hope you found this useful. Bye-bye.